Anyway, I've got good news. I wound my coil to do a test resonance check on the transformer laminations, and I've hit the nail right on the head. Because if you remember, when I was running tests with the generator, the frequency that I wanted to achieve was around 240 hertz. Now look at this. Peak to peak at 1 times 1, by the way, so it's not actually 30.4 volts, it's actually divided by 10, so you can work that out, because I didn't want to mess up with all my adjustments on here. I just flipped the switch on the probe. So the waveform is peaking at 30 volts, even though it's not actually 30 volts, but it gives me a better range anyway for testing. It's peaking at 30 volts at 233 hertz, right? Okay, so I've got my frequency generator. I'm using my, oh, sorry about all the wires trailing everywhere. I'm running my frequency generator at the moment, so it's a bit twitchy actually on the frequency, but when I adjust this knob, watch what happens to the peak to peak voltage and the frequency that we're running at. I'm going to try and do this, but my back is killing me, so but it's going to be a bit awkward. I hope you can see this okay. As I turn the knob, as I turn the frequency up, it's a bit twitchy because I'm at the bottom end of the scale. See, the peak to peak voltage drops there, and the frequency rolls off, rolls up to 350 hertz. Oh, I don't know if you can see that. Oh, I hope you can. Just a minute. Oh, I'll try and get closer to it because it's hard to get it on camera. So it's twitching, so I'm at the bottom end of my preset. At 24 volts, it's rolling off, you see. As I go lower in frequency, if I go lower in frequency, it just, this way, it just completely snubbers it out. Look, it starts, the waveform starts to clip. You can see it's jumping around because this flipping pot's dirty on my frequency generator. So it rolls off completely, just snubbers it out when I go too low. So at about there, it starts to come in. It's about 140 hertz. Oh, damn pot. I'm just going to wiggle this pot around a bit. A minute, hang on. I've got a dirty bloody pot. It's really annoying when that happens. Right, let's see if I can get it a bit better now. Oh, I'm going to have to take it apart and squirt it. Right, I'm trying to get this. Now look at the peak to peak. I don't know if you can see that. 33 at 170. It's about here. It's the resonant frequency is around. Damn thing twitching like a bugger. Hang on. I can't hold my phone very well while I'm. Hang on. Let me just. I tell you what. Let me just prop the phone up. Let me try and get the phone over here. Just a minute. I'm going to get my stand. I'm trying not to demolish everything. I'm going to put the phone on this stand so that you can see a bit better. Then I will have to hold the damn thing, you see. Come on. Stay up. Right, if I get the phone in here. Just a minute. I don't want to drop it. Right. Okay, let's see if it's a bit high, I know. Right. If you watch the scope while I'm adjusting the frequency, is it? Oh, I can't tell if I've got it pointing the right way now, because I put it in the. Hang on. Right. Okay. Just watch the oscilloscope while I'm twitching. What we're interested in is the peak to peak voltage and the frequency. My aim is around 250, 260 hertz. Right. Let's just twiddle this slowly if I can. I'm just nudging it. That's going higher slightly. Well, the waveform's fairly clean at around 240. Actually, I went out of wire when I was winding the transformer core with 22 SWG wire. I actually ran out of wire, so there's not enough wire on there anyway. But if I add more wire, the frequency will be even better, even closer to what the target is. Because at the moment, as I go up in frequency, look at the voltage on the peak to peak, it drops off. It's 26 there. Oh, this flipping pot. Look at that, it's dropped to 20 there. So higher frequency, it rolls off in the peak to peak. So if I'm just going to move this quickly a bit. What is wrong with this damn pot? I'm going to have to squirt some alcohol in it or something. Oh, if I remember rightly, these are sealed pots as well. I'm just going to let me just turn it up a minute I'm just going to turn it off while I just wiggle the pot, because it's best if you wiggle them when they're turned off actually, to clean them. Just give me a minute. So I want around 245 to between 245 to about 260 in hertz. Well, let's turn it back on again. It's a little bit less twitchy. Right. That's a bit low. I haven't used my frequency generator for a long time, that's why it's got a bit dirty in the pot. So the voltage, the peak to peak is going up as I approach the resonant frequency. Let's go to triangle waveform. Maybe it'll be a bit more stable. Alright, I'm not sure. Actually, the transformer will smooth it out, you see. Let's see. Let me just switch to square. What is the square wave? Oh, that's not the way I want. Sorry. This is triangle. Right, let's try the triangle waveform. Right, look at that at 42. So if I get a bit more wire on there, it'll be bang on. I didn't get quite enough wire on it, but I am out more or less at my resonant frequency, which is very close. I mean, around 300 hertz is not bad. It's not bad at all. Is it 300 hertz? Actually, I'm just turning. That's in. As I increase the frequency, the voltage on the peak to peak drops. So let's just go up to a higher. Let's go to medium. That's medium frequency. Let's just tune that. I actually need to increase my time base. Just a minute. Oh, falling over myself. I'll just increase the time base a bit. Right. It's right at the bottom of the scale. I need to sort this frequency generator out sometime to give me a little bit better tuning at lower frequencies. because it's mainly for higher frequencies. I'm going to go back to sine. Let's go to square actually. That's square. Look at the bloody peak to peak at, well, I don't know what voltage, what frequency we're at because it's not showing up. That's at, actually that's at 561 hertz. Yeah, definitely need a bit more wire on there. Definitely need a bit more wire on there. As I go up in frequency, well that is square wave anyway. The generator doesn't produce square waves. Go back to sine. Actually I need to turn the gain down. Let's go back to square. Turn the gain down a bit. Right. I'll bring the gain back up a bit. That's twitchy as well. The picking gain's twitchy. Yeah, it starts to come right up on peak to peak at about what is it? I have to get a lock. Around 300 hertz, I would say. No, that can't be 300 hertz. About 600 hertz. And we're going back to sine wave. To bring the gain back up. Right. So it starts to distort the waveform at about when I go really low. So it's happy at about 400 hertz, which is not far off my mark. It starts to warp. It starts to distort. The waveform starts to distort when I go too low. And this is connected across the transformer coil, by the way, so to determine what the resonance of the core is. As my frequency goes up, the output peak to peak is dropping off, it's rolling off. It's hard to tell because the signal generator is coming directly into the coil and it's tapped off to my probe directly from the same point, so you don't get a very accurate reading when you connect it directly like that. Normally get it from the secondary winding that you're measuring from, really. But I haven't got a secondary winding on there at the moment. Let's go up to a higher frequency still. Let's go right up. Oh, that's really super high frequency. That it's still showing a bit on there, but it's it'll be clipping the waveform pretty bad at that frequency. So back down to the minimum where I should be. Right. So it's actually a bit more stable now that I've been using it a bit. Oops. Right. So 280 hertz. And the peak to peak is about 32 there. And it starts to roll off as I go lower, look. So if I go even lower, I've got, stop it here. Go lower, oh it's actually going back up again, that's weird. I don't know, I'm gonna go, oh, it's jumping around. No, it's actually going higher there. If I go really low, it drops right off, look. The peak to peak, oh it's gone off now. Right, at that point there, oh shit. Sorry, I'm having trouble with this pot. Right, it's rolling off. I can't even see what frequency that is. Probably about 20 hertz or something. That's probably why it's not measuring it. But it rolls off at that point, I think, and it starts to peak again. The peak to peak is up and down all over the place because I can't get this pot to work properly. Stupid thing. It just jumps. I must be at the end of the pot. That's probably what it's doing. I don't know. There's some crap on the pot. That's what it is. Right. I'm trying to turn this really slowly. Yeah, I think I'm pretty close to my resonant frequency because you can see the waveform starting to distort there. It's got a little hump on the rise time. So that is very close. That's where the transformer's starting to dampen the waveform. Come back a bit gently. Anyway, as I say, I'm gonna have to order more wire because I've got I can't afford. I don't know if I can afford it this week. Actually, coming Monday, I don't know if I got the money to do it this Monday, but I need to get some more 22 SWG. I'm gonna need to order a fair bit actually. I probably need to get 2 spools of that. It's gonna cost me 30 quid. I'm still adjusting it slowly. It's not so bad when I get into the middle of a trim pot. I can move it quite easily up at the higher frequencies. Right, back down again. Twitching on me again. Flipping thing. Yeah, that seems to be quite stable. It's about that. It seems to be quite good. Got good peak to peak as well. So that seems to be the resonant frequency anyway. If I just click the switch to go to high, you can see the voltage on that highest drops to 24. Go to even higher, it's still at 24. Even higher, it's stopping to 23. So that one is definitely higher. So it's closer to the resonant frequency there. Yeah, I can't measure it properly without having a second winding on there as a pickup coil to determine what's passing through, really. But yeah, let me just get my phone over here. Oh my god, it's burning up again as usual. Come out, you bugger. Not dropping. Right. Bloody heck, phone's hot. So, yeah, what I really need is another winding on here to act as a pickup coil to see what frequency is passing through the core. But yeah. Anyway, that's something I wanted to do, was to test this frequency, and I found out what it is. And while I'm at it, I won't do it right now because the phone's too hot. But I'm gonna, at some point, I want to find out what the resonant frequency these are, because the ones I made before. Because believe it or not, I never actually checked them. I never even bothered checking what frequency these resonate at. But to be honest with you, I'm pretty sure they'll be too high. That's why I'm having trouble with my generator. It's not working the way I want it to work, because I'm pretty sure that these resonant frequencies will be in the kilohertz range probably. They won't be in the hertz range, which is why I wanted to make these bigger chokes. And I've actually got two of them now. I haven't got any coils on this other one. I've just got two ready now. I need to wind coils on all of these. They want to be dual coils as well, you see. Pretty heavy. At least I've got a partial coil wound on here. It's only half full. If I don't enough 22 wire, SWG wire, and I was able to fill that bobbin up with it, it would have been probably just bang on. Well, I just didn't have enough wire. I had to use quite thick wire because I didn't want to increase the DC resistance. I didn't want to increase the DC impedance too high, because you lose power when you're feeding it through a choke. By using lower, thicker wire, I could basically, there's a fairly small voltage that's going through this, but a high current. We're talking about, well, not really high current, but we're talking about what, 100 milliamps or so. But yeah, so I'm using thicker wire really to minimize losses, but I wanted to be able to drive enough reactance through this core material. And using thin wire, it would be probably a waste of time. I'd probably end up with something like 3 or 4 milliamps on the output section, which is useless. So that's why I went with a 22 SWD wire. So yeah, that's all I've got for you at the moment. So yeah, this is the problem. The probe is connected directly to the same terminals as the input frequency signal, which is why we're not getting a true, well, we're getting a reasonably close idea of what the resonant frequency is, but we can't get some of this stuff's just bleeding straight through, you see, from the signal generator. It's actually going straight back through with the coil not dampening it enough. That's because we're just testing it in parallel, which is always a problem when you're doing it this close. If we had a second coil and we were measuring the frequency coming out the second coil, then we will be able to see exactly what frequency pass through we were getting on it. Well, I'm not going to do that right now. I'm just tired. My back's still not right. I'm going to get early night tonight. Yeah, it's been a long day. Anyway, thanks for watching.